Mr. Safari has asked me to put together some work solutions for you on exercise 7D. So I'll be going through the questions that have been set for you, probably quite slowly. Before I start, I make sure I've got my double angle formulae and my addition formulae ready because I think I'm going to need them. And we're going to start on question 1. So question 1, there are 4 parts to this question. All 4 parts are asking you to solve for theta, and all 4 are asking you to solve in the range of a full turn of 0 less than or equal to theta, which is less than 360. So let's start with question 1a. So we've got 3 cos theta equals 2 sine theta plus 60. Well, you'll notice straight away that we've got an addition here. So the first step that I'm going to make is to expand this using the addition formula for sine and see what we end up with and see how we can simplify from there. So we're keeping the left hand side the same. So we've got 3 cos theta, and that's going to equal 2 lots of sine theta cos 60 plus cos theta sine 60. Okay, now, thinking about what to do now. Well, cos 60 is a half and sine 60 is root 3 over 2. So let's pop that in. As you can see, we've got 2 lots and we've got some halves in here, so they will cancel quite nicely. So we end up on the right hand side with sine theta plus root 3 cos theta. And on the left hand side we've still got our 3 cos theta. Okay, let's isolate the cos as separate to the sine. So let's subtract root 3 cos theta from both sides. So we get 3 cos theta minus root 3 cos theta equals sine theta. Ideally, we've got a sine and a cos, so we're going to be working towards finding, getting tan involved somehow, I think. So the best thing to do now is to factorise the cos part so that we have cos only appearing once. So 3 minus root 3 cos theta equals sine theta. And now I can divide both sides by cos. I end up with 3 root 3 equals tan. Okay, that's a bit nicer. So we're going to pop tan to the minus 1 of 3 minus root 3 into our calculators and see what happens. That gives us theta equals 51.7. Now we're asked to put the solutions to 1 decimal place, so be careful here, make sure you round properly. 51.7 is in our range, so that's good, we can keep that one. This is tan, and we've got a full turn, so we would expect at least, well, we'd expect 2 solutions, because it will repeat. So, because tan repeats every 180 degrees, we're going to do 180 plus 51.7 to get the second solution in range, and that will give us 231.7 degrees. So part 1a, 51.7 or 231.7 to 1 dp. Okay, so let's have a look at part b. Another addition formula here. Everything's in sine, but obviously that's going to change once we expand the addition formula for sine out. So let's take the left hand side and rewrite this as sine theta cos 30 plus cos theta sine 30. And then we've got the plus 2 sine theta equals 0. Right, put the real values in for cos 30 and sine 30 now. So we've got root 3 over 2 sine theta plus a half cos theta. I'm presuming you know your exact trig values. but luckily you've got a calculator nowadays anyway, even if you don't know them. Okay, let's collect together the signs and factorise, just like we did before. So I've got root 3 over 2 and 2, lots of sine theta. And I'm going to take my cos over to the other side. Okay, again we've got sine and cos, so we're going to be working towards trying to get tan involved. So I'm going to divide both sides by cos. So it becomes sine over cos, which is tan. I end up with minus a half here. And then I'm going to divide both sides by root 3 over 2 plus 2. I'm afraid mine's a bit scruffier than Mr. Safari's, so I'm hoping you're all following this okay. Okay, not very pleasant, but carefully pop it in your calculator when you do tan to the minus 1. And because it's negative, it's going to be a different quadrants answer, actually. I think you're going to be thinking about your cast diagram. It's probably going to be quadrant 4, I would expect. So we're going to get that as our answer. It's not in the range that we need, but in order to get it in the range, all we've got to do is add on 180 to get it into 0 to 360 that we're looking for. So if we add 180 onto here, we get our first solution, which is 170.1 to 1 decimal place. Don't forget the degrees. And then we're going to add 180 on again to get the second solution in range. So we're going to get 350.1. Okay. And that's part B. C. A little bit more tricky, this one, and warning bells always go off for me when I have two different amounts of turn in one calculation. So I think it means we're going to have to be a bit sneaky here somewhere. But starting off, as we always do, by expanding these addition formulas out and seeing what we can do, having a look at it. So the addition formula for cos, first of all. So we're going to get cos theta cos 25 minus sine theta sine 25. And to that we're going to add on the additional for sine. So we've got sine theta cos 65 plus cos theta sine 65 equals 1. It's all we've done is expand out. I've forgotten all my degree signs here. Don't you do that. Okay. Oh, we've got 25s and 65s, and you'll find if you put those in your calculator you get something really nasty as well. So it's not as if we can put real values in and be a bit sneaky here without rounding, and we don't want to do that because we want exact values. So we've got to work something else out. Well, hopefully you notice that we've got 65 and 25, and 65 and 25 gives us 90. And this is incredibly useful because if we think about how we would go from sine to cos and cos to sine, the cos graph is a 90-degree shift of the sine graph. So we should know, or you should know from your identities and from your work you did in year 1 on trig, that sine 90 minus theta equals cos theta, because it's a shift of 90 degrees. And similarly, cos 90 minus theta equals sine theta. So what does that mean for what we've got here? Well, it means that cos 25 is sine 65. That's the relationship between them. Because 90 minus 25 there would give you cos 65. Yeah. And sine 25 equals cos 65. This might be one that you want to ask Mr. Safari about when you get into school if you're still not 100% about it. So what we're going to do is use this to change everything in terms of cos 65. No, in terms of 65, not cos 65. Get rid of the 25s. So I'm going to rewrite this now as cos theta sine 65 minus sine theta cos 65 plus sine theta cos 65 plus cos theta sine 65 equals 1. Now, minus sine theta cos 65 plus sine theta cos 65 will disappear. Cos 65 and another cos 65 means that I've got 2 cos theta sine 65 equals 1. Okay, now this is something that I can do something with. Dividing both sides by 2 sine 65. Cos theta equals 1 over 2 sine 65. So doing your shift cos will get us our value for theta. And if we pop that in our calculator, we get 56.5 degrees. And that's good, that's in the range that we want, between 0 and 360. So our second solution for cos, well, that's going to be, because of the symmetry of the cos graph, that's going to be 360 minus the first solution. And that gives us 303.5. We've got a full turn, we're expecting 2 solutions in the range. Okay, so that was a bit sneaky, that one, a little bit harder. So finally, part D. So we've got cos theta equals cos theta plus 60. Another addition formula. So let's expand that. So we'll keep cos theta on the left, and we're going to rewrite the right as cos theta cos 60 plus sine theta sine 60. Okay. Well, cos 60 is a half, and sine 60 is root 3 over 2. So rewriting this as a half cos theta. We've still got a cos theta here. Sorry, that should be a minus, shouldn't it? You're all shouting at me, I can hear it. There we are, minus that. So this is going to be minus, apologies for that, root 3 over 2, sine theta. Okay, well, let's get all our cos thetas on one side. So I've got a whole cos theta and I'm taking half off it. So I'm going to have a half cos theta on the left. And that's equaling minus root 3 over 2 sine theta on the right. We've got cos and sine again, so we're going to end up with tan. Let's divide both sides by cos theta. Sorry, minus root 3 over 2 tan. And then divide both sides by minus root 3 over 2. Okay. Now the 2's will disappear and we'll end up with minus 1 over root 3, which we do not ever write like that because we rationalise it to that. Okay, so we're going to do shift tan, so tan to the minus 1 of minus root 3 over 3. Already I know because it's negative we're not going to get an answer in the correct range, but that put us off. We get minus 30 degrees. But in order to get it into the right range between 0 and 360, we're going to add 180 onto it. So our first solution is going to be 150, and our second solution is going to be 180 on from here, which is 330 degrees. So those are our 2 solutions for part D. Right, question 3 of exercise 7D. Right, we've got a long expression on the left-hand side here, cos theta cos 30 minus sine theta sine 30, and that's equal to a half. And we're asked to solve it between 0 and 360, inclusively this time. So you should recognise the form of this. It's one of the addition formulae, isn't it? And it's actually the cos one. So this is in the form of the cos A plus B addition formula. So I'm going to pop it into that. So A will be theta and B will be 30 degrees. So we can rewrite this left-hand side as cos theta plus 30 degrees. And that's equal to a half. Okay, well, we've changed the angle that we're working at now, so I need to change my range accordingly. We're not working with theta, we're working with theta plus 30, so actually the range that we're looking for when we do our solutions is now gone up by 30, so let's just make sure we keep on top of that, because that can cause problems. Okay, so there's our new range. Right, straightforward really. We're going to do cos to the minus 1 of 0.5. Which you should all know without looking it up, is 60 degrees. So theta plus 30 equals 60. Okay. We're looking in the range between 30 and 390. This is in that range, so that's good. So we want another one within this range, because this is still a full turn, just from a different starting point. So we'll expect two solutions. It's cos, so we're going to do through 60 minus 60 for the other solution, which will be 300. Okay, so theta plus 30 equals 60, or theta plus 30 equals 300. So theta must be 30 or 270. Straightforward, that's part A. Okay, part B. Well, we've got root 3 cos theta minus sine theta equals 1. And it's a part B, so we're assuming we're having to use part A to some effect in order to help us. Well, let's have another look at what we started with on part A. We had cos theta cos 30 minus sine theta sine 30. Well, we know what cos 30 and sine 30 are, so let's substitute them in and see what we end up with. So we end up with root 3 over 2 cos theta minus a half sine theta equals 0.5. Now let's have a look at that compared with this. Okay. What I'm going to do is I'm going to multiply both sides by 2 of this. Well, hopefully now you can see that this and this are identical. So this equation here is exactly the same as part A. So the solutions are going to be exactly the same. Make sure you explain yourself, please. I know you're mathematicians, you don't like writing sentences. Nor do I, to be honest. There we go. And that's question 3. So moving on then, let's have a look at question 6 that you were set as well. I would rather like question 6. It's a nice little geometry question, really. We're given a fair bit of information. We've got to start by deciphering what it is we need to do. In triangle ABC, AB is 4 and AC is 5. Angle ABC is 2 theta and angle ACB is just theta. So what are we going to do? Well, before we do anything else, we're going to draw a diagram, of course. I'm sure you're one step ahead of me and you've already got yours drawn. Triangle, I mean, obviously, it makes no sense. It's any old triangle. I don't know that it's drawn anything like to scale, so it doesn't have to be. ABC, A to B is 4 centimetres. A to C is 5 centimetres, and we're told that ABC is 2 theta, and we're told that ACB is 1 theta. Okay, there we go. We don't know what type of triangle it is, so we can't assume it's right angled, so Pythagoras and trigonometry are useless to us. However, we do have angle and their opposite side. So we can use the sine rule. We know the angle opposite, if you divide by the angle opposite, it's the same relationship both times. So I'm going to say, using the sine rule, 4 over sine theta is equivalent to 5 over sine 2 theta. They're the same relationship. And I'm going to try and rearrange this into something that I can use. So let's cross multiply. I'm going to multiply both sides by sine 2 theta. So I'm going to end up with, I'm going to have 4 sine 2 theta on here. And multiply both sides by sine theta. There we go. Now we've got sine 2 theta. Don't like that, I want everything in terms of the same thing, so I'm going to use the double angle formula for sine. So I'm going to rewrite this as 4 lots of 2 sine theta cos theta, using the identity. Okay. And that's equal to 5 sine theta. So I've actually got 8 sine theta cos theta. Right, we're getting somewhere. So let's get all the signs on the same side. So we've got 8 sine theta cos theta minus 5 sine theta. And I'm going to factorise. So I'm going to pull the factor of sine out because there's sine in both of these. So I'm going to say sine theta brackets 8 cos theta minus 5. Sorry, I forgot to put my equals 0 there, equals 0. Right, so solving this, if it's equal to 0, either sine theta is equal to 0 or 8 cos theta minus 5 is equal to 0. If this is equal to 0, then cos theta equals 5/8, because we add the 5 and divide by 8. So we've got 2 solutions. Let's see what happens if we solve them. Sine to the minus 1 of 0, you should know, is either 0 degrees or 180 degrees. Now, we're looking at the angles of a triangle. It can't be 0 because then there's no angle there at all, and it can't be 180 because then you can't make a triangle. So we're going to discard both of those solutions because they are nonsensical. So we are just looking at our cos theta results. So we're going to do cos to the minus 1 5/8 using our calculator, and we get 51.3 degrees. That makes more sense. We could look for other solutions, but they won't make sense as far as a triangle is concerned. If we did 360 minus 51.3, we're going to have a result more than 180 degrees, so it can't make sense here. So theta is 51.3, which means that the other angle, 2 theta, must be 102.6. So that's the end of question 6. Right, question 7 of exercise 7D. Show that 5 sine 2 theta plus 4 sine theta equals 0 can be written in the form a sine theta bracket b cos theta plus c close bracket equals 0. Okay, so we've got 2 different angles here. We've got one which is double the other, so guess what? We're going to use the double angle formula to try and work this out. So I'm going to replace sine 2 theta here with the identity for sine 2 theta, which is 2 sine theta cos theta. So this expressional term here will become 10 sine theta cos theta. Now I've got plus 4 sine theta. Okay, both of these terms contain sine, so I'm going to factorise. 10 and 4 have a common factor of 2. They've both got sine theta. So 5 cos theta plus 2. Okay, we've pulled the sine out and the highest factor, so now we have an equation in the form that we've been asked for. And it does ask us to state the value of a, b and c, so we've got a equals 2, b equals 5 and c equals 2. That was part A. So really, once you know your double angle formula, that one's more straightforward. Okay, second part, hence solve. So we've got 2 sine theta, 5 cos theta plus 2 equals 0. So either this part here is 0, Wally, or this part here is 0. So let's start by taking the sine. So we've got 2 sine theta equals 0. So of course sine theta must equal 0. So theta must be 0 or 180. 0 is included in the range, so that's fine. We've got 2 solutions here. The right hand side, we've got 5 cos theta plus 2 must equal 0. So rearranging that, we get cos theta equals minus 2/5. Cos to the minus 1 of minus 2/5 gives me the answer 113.6 degrees. So that's one solution for cos. The second solution in this full turn will be 360 minus the first, which will give us 246.4. So we've got our 2 solutions here. So tidy it up by just writing our solutions at the bottom in order. So we've got 0, 113.6, 180 and 246.4. Yes, that was question 7. So we'll now have a look at question 10. Now this is a little bit more stinky. We've got some identities. They don't look very nice. Don't worry, it's going to be fine. With identities, we always take either the left-hand side or the right-hand side and manipulate them to look like the other. So always start with a more complicated looking side and always tell the examiner what it is you're going to be doing. So I'm going to say I'm going to take the right-hand side. Okay, so I've got 2 tan theta over 2 plus 1 plus tan theta, sorry, tan squared theta over 2. Okay, well 1 plus tan squared theta is sec squared theta, and you should know that from your identities. So I'm going to rewrite this again. With the denominator being sec squared theta over 2. Okay, now this is the same as saying I've got 2 tan theta over 2 multiplied by 1 over sec squared theta over 2. Now, as you know, sec squared is 1 over cos squared. So if I've got 1 over sec squared, I've got 1 over cos squared, which is cos squared. So I can now rewrite this as 2 tan theta over 2 cos squared theta over 2. Okay, so 1 over cos flips it back up the other way. Okay, so where do we go from here? Well, tan is sine over cos. So let's start by popping that out in full, and we're multiplying by cos squared theta over 2. So this one will cancel with one of these. Okay, so I've got 2 sine theta over 2 cos theta over 2. Now this is where we bring in our double angle formula. So sine 2a equals 2 sine a cos a. So this here is in this form. So I can now rewrite that as sine theta, because if we halve this, we get this, and we want 2 of them. Okay, so using our identities, this equals the left-hand side. And we put as required, or if we're being fancy and want to look clever, we put quantus est and strandum instead. Okay, that can make you look a bit silly though, so don't always put that, especially if you're wrong. Right, so quite a meaty one, but using the identities you've learnt so far. So let's have a look at the second one. Hopefully it'll be very similar, and it is actually. Okay, so cos theta is identical to 1 minus tan squared theta over 2 over 1 plus tan squared theta over 2. So again, it's an identity, so we can't swap sides, we can't do any manipulating across this sign. So we're just going to take the right-hand side. Okay. And again, the denominator is actually sec squared theta over 2, because 1 plus tan squared is sec squared. So let's rewrite this. I've got 1 minus tan squared theta over 2 divided by sec squared theta over 2. Now this is 1 over cos squared, and we've got 1 over cos squared again, so let's rewrite this again as 1 minus tan squared theta over 2, which is your numerator, and now that's times by cos squared theta over 2. Okay, we can expand out this bracket now. So I've got cos squared theta over 2 minus tan squared theta over 2 cos squared theta over 2. Rewriting tan squared theta over 2 as sine squared theta over cos squared theta. You can see that these will cancel. So I end up with cos squared theta over 2 minus sine squared theta over 2. And again, using our double angle formulas. So cos 2a equals cos squared a minus sine squared a. Okay. So this is cos squared a minus sine squared a. So cos 2a must be cos theta. Equals left-hand side as required. Okay, so that's part 2. Now, we use this information for the second half of the question. So by writing as quadratics in tan theta over 2, solve in the interval 0 to 360. First of all, sine theta plus 2 cos theta equals 1. Right. So from our first part, we know sine theta equals 2 tan theta over 2 over 1 plus tan squared theta over 2. So what I'm going to do is I'm going to say let x equal tan theta over 2. So sine theta will be 2x over 1 plus x squared. Okay. And from part A, we also know that cos theta equals 1 minus tan squared theta over 2 over 1 plus tan squared theta over 2. And again, using x equals tan theta over 2, we can rewrite cos theta as 1 minus x squared over 1 plus x squared. Okay, now that we've sorted this out, we can substitute these into our equation. So instead of sine theta, we've got 2x over 1 plus x squared, and I'm going to add on 2 lots of cos, and that's got to equal 1. Okay, our denominator's the same, so what I'm going to do is multiply both sides by 1 plus x squared. Okay, and expand and simplify. 2 times 1 is 2, 2 lots of minus x squared is minus 2x squared equals 1 plus x squared, and I want to, because it's a quadratic, I want to get all the terms on one side, and it's much easier for my life if I make the x squared part positive. Why make life any more difficult? So I'm going to add 2x to both sides. I'm going to put everything over to the right hand side. Add 2x to both sides and I'll end up with 3x squared. I'm going to take away 2, so that's going to become minus 1. I'm going to take away 2x. Okay, so I've got quadratic. This one actually will factorise quite nicely. So I have the solutions x equals 1 or x equals minus a third. Right. At this point, we need to substitute back in for x. So I've got tan theta over 2 equals 1 or tan theta over 2 equals minus a third. Remember, we want solutions in the range 0 to 360. We're working with theta over 2 now, so when we look at our solutions, we will be looking for them in this range instead. We need to halve the values. So tan theta over 2 equals 1. Shift tan of 1 gives me 45 degrees. If I add on 180 to find another solution, we're going to go out of range. So it's only that solution. So if theta over 2 is 45, then theta equals 90. One solution. Shift tan minus a third gives me the answer minus 18.43. So theta over 2 equals minus 18.43. It's not in range, so I'm going to have to add 180 to it. And I get 161.6 degrees, and that is in range. So if theta over 2 is 161.6, then theta must be 323.1. Okay, so our solutions for theta are 90 and 323.1. Okay, so that's the first part of B, and the second part of B is very similar. So let's go through that now. Using the same method, we need to evaluate theta with 3 cos theta minus 4 sine theta equals 2. Okay, substituting our values of sine and cos in again. We've got 3, so I first of all let x equals tan theta over 2. I've got 3, 1 minus x squared over 1 plus x squared. That's your cos value, remember from last time. And I'm taking away 4 lots of the sine, which was 2x over 1 plus x squared, and we want that to equal 2. So similarly to last time, we're going to multiply through by 1 plus x squared first to get rid of the denominators. So I end up with 3, 1 minus x squared minus 4 lots of 2x equals 2, 1 plus x squared. Okay, a simple bit of manipulation now. We're going to expand and simplify and put as a quadratic. So I've got 3 minus 3x squared minus 8x equals 2 plus 2x squared. Now again, I don't want to make my life any more difficult than it needs to be, so I'm going to make sure my x squareds are positive. So I'm going to pop everything on the right hand side to get rid of this negative x squared. So adding 3x squared to both sides, we get 5x squared. Adding 8x to both sides, 8x becomes over here, and I'm taking away 3 from both sides. I end up with a quadratic. This one doesn't factorise, it's a bit stinky, so I suggest you can use the formula or complete the square, but if you show your workings, popping it into your calculator isn't going to be the end of the world here. So the solutions are minus 8 plus or minus root 84 over 10. Again, x equals tan theta over 2. So we've got tan theta over 2 equals minus 8 plus root 84 over 10, and tan theta over 2 equals minus 8 minus root 84 over 10. Okay, and we're working with theta over 2, so we've got a half our value, so we're on 180 again. Okay, so shift tan of this minus 8 plus root 84 over 10 will give you theta over 2 equals 6.6458. If we added 180 onto this, we would be out of range. This one's in range. There's only going to be one solution in this range because it's just one instance of the tan graph. So this is our solution, only solution here. So theta is going to be double it, 13.3. And again, shift tan minus 8 minus root 84 over 10 gives us minus 59.8. This is not in range, so I'm going to add 180 degrees to pop it into range. And that gives theta over 2 equals 120.2, and this now is in range. There's not going to be another one in that range. So multiply by 2 to get theta 240.4. So our two solutions are theta equals 13.3 degrees and 240.4 degrees. That's question 10. That's quite nice, wasn't it?